With level 6.4, we are moving into graphing. So just like every other chapter that we've talked about so far this year, we've gotten to the point where we've seen these functions a bunch, so we want to look what the shape of the graph is. So before we start graphing these, I want to point out a couple key terms, and this is the type of equation that we're building towards. We're not going to get to this yet, but by the end of this level, you should know what A, B, C, and D all do to the graph. And I think we kind of know that A is just going to be a vertical stretch, and B and C kind of move it left and right, and D is our up and down. So we've seen these just in different things. We were talking about those as translations before. So before we start, a couple key terms that I'm going to be using when we're talking about graphing trig functions. So the first one is amplitude. So just like in your car, if you're turning up the volume, you're turning up the amplitude. Amplitude just means the height, H-E-I-G-H-T, height of the wave, and also means a vertical stretch. And that's what A does. So that's that A term, A for amplitude. That's pretty easy to remember. Our period means the time it takes to make one revolution. So what we're looking at is how long does one of these take to go around one time on the unit circle. And this is, the B term really influences this. So period always goes with the B term. And the phase shift is moving the graph left or right. So if we're ever talking about phase shift, we're just moving the graph left or right. And this involves B and C. And the other thing I want to talk about with phase shift is it influences our starting position. So we've got amplitude, we've got period, and we've got phase shift. So to make our lives a lot simpler to start with, we're only going to be focusing on equations that look like y equals a sine b of x, where a is the amplitude, and when we talk about amplitude, we're actually talking about the absolute value. Because if you're turning the speakers up or down on your radio, you're not saying, oh, change the amplitude of the music by negative 2 decibels. No, you say turn it down. So with amplitude, we're always talking about the absolute value. So the amplitude is always positive or negative. But if we have a negative amplitude, it could just flip our wave. Same thing with period. So period, we use T, capital T for time usually, so the time it takes for one revolution. So capital T for period equals 2 pi divided by B. So if B is a large number, think of it this way. If B is large, then it revolves around circle faster. So the larger the B is, the shorter the amount of time it takes to go around the unit circle once. Likewise, if B is a fraction, then the slower it revolves around, and let's just say the unit circle. So not just any circle, but we're only going to be focusing on the unit circle. Okay? So if I say it's going to take you half as long or twice as long, that means our period is going to be over a fraction, and when we ever divide by a fraction, it means it takes longer. That's all we're getting at. All right, so the big thing, if you want to take out your unit circle as we go along with this, we're going to be tracing out the graph of sine. So I'm going to draw our initial time plot, and all we're going to graph is one revolution. So to go around the unit circle one time, we go out to 2 pi. And where we start is 0. Now you might be saying, okay, those are our two endpoints. If we spin around the unit circle once, we're starting at 0, we go to 2 pi. Other key points of that we want to look at. So halfway between here, so if we go just about halfway, would be pi. Another key point that we want to look at is halfway between 0 and pi, so we're going to call that pi over 2. And then halfway between pi and 2 pi, we're going to look at 3 pi over 2. And we're always going to have we're always going to have 5 points for graphing a sine or a cosine wave. So now, once we have these angles, we're going to look at the sine graph. Remember, sine is the y values on the unit circle. So let's look at the y values as we go around. So first off, on the unit circle, the sine of 0 is 0. Okay, so we got our point. There's 1. And I'll do this in a blue color. So the sine of 0 is 1. The sine of pi over 2, so the sine of up here, is 1. So we put our dot at pi over 2, comma 1. The sine of pi, we go in our unit circle again, we see that it's 0 again. The sine of 3 pi over 2 is negative 1. And then the sine of 2 pi is back to 0. So now, all we have to do in order to graph this is connect our dots. And I kind of like to make each one its own little curve. And then for math speak, we're going to put these little dashes because our wave keeps repeating the same cycle. It goes up and down, up and down. Same if we go back in time. It goes up and down, up and down. So when we're graphing, and that only asks for one revolution, we're just going to go from 0 to 2 pi. And this is what sine looks like. All right, flip it over. We'll do a couple more. All right, so with example 2, we are graphing 3 sine x. So our amplitude here, just if we were going to follow along, our amplitude is 3, or the absolute value of 3, which is 3. Our period, which is going to be 2 pi over b, which in our case b is 1, so it's 2 pi over 1, which is 2 pi. So we are going to start at 0, and we are going to finish at 2 pi. So we're going to draw out our same graph again, and what the amplitude does is instead of going up and down to 1 and negative 1, our graph is going to go up to 3 and negative 3. So that's 0, that's 2 pi, cut it in half, we get pi, cut it in half again, you get pi over 2. If you add pi over 2 and pi, you get 3 pi over 2. You're going to get very familiar with these numbers. And then I'm going to put 1, 2, 3, and 1, 2, 3. And as long as our scale is accurate, I can see your x scale and your y scale, we should be good. I know some people have run into the past, people are saying, no, your scale's off. No, as long as I can see what your scale is, you're good. Okay, so same thing. Sine of 0 is 0. Sine of pi over 2 is 1, but our amplitude's 3, so we go up to 3. Sine of pi is 0. Sine of 3 pi over 2 is 3. And the sine of 2 pi is 0. So if I connect these dots, and you're like, hey, that looks exactly the same. You're right, because my scale is just a little bit different than it was on the front page. So that, when we indicate our amplitude and our period, and then our start and our finish, and if you get in the habit of writing start and finish, I think this is going to make it a lot easier. All right, example 3. We've got y equals negative sine of 2x. Okay, so our amplitude here is still the absolute value of negative 1. So our amplitude is 1. But that negative sign means we're flipped, or we're going down first. So going down. Our period, our capital T, is 2 pi over b. Write it enough times until you remember it. So that's 2 pi over 2, which is just pi. So instead of having to take a full 2 pi to go around, we're going twice as fast, which means it's only going to take pi units to go around once. Or in 2 pi, we would go around twice. So let's see. For our 1 revolution, we're going to start at 0, because nothing's shifted it left or right, and we're going to finish at pi, because we'll always finish after 1 period. Okay, so again, I'm going to draw in our graph here. And instead of going out to 2 pi, I'm going to go out to pi units. And here again we have 0. I'm going to cut pi in half, and we get pi over 2. So from here to here, we cut it in half. From 0 to pi over 2, we're going to cut that in half. If we cut that in half, we get pi over 4. And if we add these two together, well, 1/4 plus 1/2, we get 3 pi over 4. So just again, how we got these lines. We went out to our finish spot. Started at 0, we go to pi. Cut it in half, pi in half, we get pi over 2. Cut pi over 2 in half, we get pi over 4. And if you add these two together, you get your last term. Or if you want, the halfway point between pi over 2 and pi is 3 pi over 4. Now we are good. The last thing I'm going to put in here is 1 and -1. So now, normally, we would go up, but since we're flipped, since we're negative, we're going to go down first. So at pi over 4, we're -1. At pi over 2, we are 0. At 3 pi over 4, we are 1. And at pi, we are back to 0. And then if I just sketch this quickly. So these are our basic shifts that we're going to be talking about when we're dealing with pi. Next up is cosine. So once you graph cosine, or sorry, once you graph sine, we're going to get its complement, which is cosine. So just like we said, with sine, you were looking at the y values on the unit circle. Cosine, you're looking at the x values on the unit circle. And here's the nice thing. When we start off in the simplified version, almost everything applies from what we were doing with sine to cosine. It's just a slightly different function. So what we're going to do, just to start, so we get in the hang of it, our amplitude is 1. Our period is 2 pi over 1, which is 2 pi. So both of those are pretty familiar. So then we're going to start at 0. We're going to finish at 2 pi. And if you still have our unit circles out, then we're just going to be looking at the x values. So let's call this 2 pi and this 0. If we cut that in half, we get pi. If we cut that in half again, we get pi over 2. And if we cut in between here, we get 3 pi over 2. And since our amplitude is 1, we'll go up 1 and down 1, because that's the highest and lowest point, same left and right, that we can be on the unit circle. All right. So in a different color, if we go to 0 on the unit circle and we look at the x value, the x value is 1. If we go to pi over 2, the x value is 0. If we go to the x value at pi, we get -1. If we go to the x value at 3 pi over 2, we get back to 0. And at 2 pi, the x value on the unit circle is 1. And so cosine is pretty similar to sine. It's just shifted, or it's off, by pi over 2 units. So again, you can do this little tail thing, which means it goes down. So what I mean by when we say that cosine is pi over 2, or sine, but just pi over 2 shifted over, well, if I cover up this first part, that looks like a negative sine value. If I went backwards pi over 2, then we'd get almost our full sine curve, just shifted to the left pi over 2. So that's what I mean by how cosine and sine are related. They're kind of just two waves that are out of phase a little bit. All right, so with example 5, we're going to figure out the amplitude, we're going to figure out the period. So amplitude is the absolute value of 2, which is just 2. Our period, our capital T, is 2 pi over b, which is the number inside. So that's 2 pi over 3. Fractions. Fractions are our friends, so this is going to be easy. So we're going to start our graph at 0, because it hasn't been shifted left or right, and we're going to finish our graph at 2 pi over 3. Okay, so we have everything we need, and we're just going to graph our cosine. So the highest place we're going to be is 2, and the lowest place we're going to be is negative 2. Here we got our 0 value, and if we go out to 2 pi over 3, then we've got our graph. So how do we do this by hand? Cut 2 pi over 3 in half. Cut that in half. We get, here, let's make sure that's better. So half of 2 pi over 3 is pi over 3. Half of pi over 3 is pi over 6. If we add pi over 6 plus pi over 3, we get pi over 2. So this might look a little weird, but these values plugged into this function give us the exact same y values or outputs as we had here. So why we do this subdivision is so we can get our basic shape of our cosine graph. So let's do light blue. Cosine at 0 is 1, so times 2 because of our amplitude, so we go up. Then pi over 6, if we plug in pi over 6 here, it's the same as plugging in 3 times pi over 6 is pi over 2, which is 0. If we plug in pi over 3, we get negative 2 in our case. If we plug in pi over 2, we get 0. And if we plug in 2 pi over 3 here, we get back to 2. So the last little bit is connect the curves. And if you are having trouble drawing these curves out, starting, it's okay, as long as we get this basic shape. And it's important that we don't just play connect the dots, but we really draw out curves. So these aren't linear, it doesn't make a V shape. It's really important that just like a wave, that we draw our curves curved. All right, so we've got the problems at the bottom. Good luck.